Hello, general chemistry students. This is Dr. Hayes. This is officially lecture 6. I'm going to go through some OWL problems and that deal with density, which is equal to mass divided by volume. So let's get started and remember that density is your destiny. All right. I'm going to come back to this one here. Let's jump over to OWL, and there will be a couple that I have worked out previously in my PowerPoint slides. We'll jump to those. Let's just look at some here. I've got my iPad and I'm gonna write here, and then you and I will work together on these. So let's take a look. Now you spend some time looking at the preparation. I'm just gonna jump into the questions. And it says a general chemistry student found a chunk of metal, friend's house. To figure out what it was, he used the ideas just developed in his class about density. We covered this in class, so you can watch video and some more details there. This has to do with volume displacement. You drop in a metal into water, it will raise the level of water exactly equal to the volume of the metal. All right, so what do we got here? Okay, so he said measure the mass of the metal. Awesome. We got a mass there, and then he dropped it into a measuring cup, found the displaced water, which is the volume of the metal. So this is the volume of metal. Calculate the density, and then we're going to identify the density. All right. Well, how do we calculate density? Density is mass divided by volume. And look at all these things here, grams per milliliter. So that means we're going to look for grams of the metal to go into the mass, and they gave that to us. And 125.6 grams. And then we need the volume of that metal, that volume of the metal there. And they actually just gave it to us. Now, in some other problems, you may have to get to it a little bit differently. So that's 19.7 milliliters. So we need a calculator. I think I'm just going to use my phone's calculator here. And let's see here. Okay, I'm just plugging in 225.6 divided by 19.7, and I got a, this looks 11.45, but this is 3 sig digs, so I'm just going to go 11.5 grams per milliliter. And looking at that list there, that looks like lead. Then 11.5, and then I come over here and type in lead, and then I can scroll down and submit my answer, and look at all those nice little green check marks there. Not too bad. And that's what you're going to work on these problems. And same thing here. I like this problem. Oh, by the way, this 2 REQ means you got to get 2 out of the 3 to get the full points. If you don't get them, then you can retry the entire group, and you can hit retry entire groups. For attempts remaining. Ooh, I must have changed the setting on here. Oh, well, okay, so you can have 10 attempts. But then you get like 2, right? Let's see this problem. The problem, calculate the mass of 15.6 milliliters of nickel. Now, this is where I wanted you guys to think about using density as a conversion factor. We spent a little bit of time talking about that. What do I mean? Well, you start with the volume given, 15.6 milliliters. And then look at what they're doing. There's a little line here, and they want you to drag these different values there. So I want milliliters on the bottom, but what am I trying to do? Milliliters of nickel into grams of nickel. So I'm going to use the density as a conversion factor. I'm going to use the density of nickel. So the 8.91 is how many grams are in 1 milliliter. So all the density numbers are how many grams of that substance in 1 milliliter. So 1 milliliter, oh, okay, I'm going to drag that to the bottom, right? And then there's let's change it. Let's go 8.9 milliliters. And then I can do the math once again on my calculator. All right, need to kind of keep that open, huh? 15.6 times 8. I got 139 to 3 significant digits. Submit answer. Didn't like it. because I know I got that one wrong. So how do I fix it? Just drag the new one there, and then I'm going to hit submit, and we got it right. Okay, well, that's nice. It's getting you to think about density as a conversion factor. So the problems will get a little harder here. So in this problem, I'm going to make this a little bit bigger now so we can see. In this problem, we've got a sphere, and it has a certain mass and a certain diameter. What is the density of the metal in grams per cubic centimeter? A couple of things here. So remember, density is mass divided by volume. Well, they give us the density or the mass already, 6.909 grams. The volume is going to be a little harder. The volume, they said, is 4/3 pi r cubed. Well, they didn't give us the radius, but they did give us the diameter. We're going to do two things with the number they did for the diameter. Number one, we'll take the diameter and we're going to divide it by 2. So that's going to equal 4.16 centimeters. Oh, millimeters. We're going to convert that number into centimeters. There are 10 millimeters in 1 centimeter. So this gets divided by 10. So it's 0.416 centimeters is the radius. Now I can go and go 4/3 pi r cubed. All right, and I got to cube that number, and that's the number that goes in there. So I just want to show you how to set it up. You guys go after the green check mark there. Notice you only have to get 1 in this. In fact, you only 1 required for the rest. That's not too bad. What is this one? This has to do with carats, and what's the volume of a 2.5 carat diamond? This in my PowerPoint slides. I'm going to try to do it here with you. No, do the slides. Go to the slides. Here we go. All right. This looks very similar, except for it looks like this one's got a different number for the number of carats. So don't copy my numbers down. Owl gives you different numbers, even though some of them may be the same. And we got diamond. It's conversion factor. So we don't want to start with that number. When it says the mass of diamonds is often measured in carats, where 1 carat equals, so 1 carat equals 0.2 grams. Two things are equal. That's a conversion factor. We're going to use that. Okay, so we want to find equivalences, and we did. Make them conversion factors and use them secondly. Find the initial value. Well, what is that? That is, what are the conversion factors? Density and the carat. Okay, I got it all worked out right here. So start with what they give me. Use the equivalency developed from the 0.2 grams is equal to 1 carat. How did I know that? Because they said it's 1 carat. Remember, I want to put the carat on the bottom, so that now that converts this number to grams. And then I can use the density with the grams on the bottom and centimeters on the top. And then now I multiply all the numbers on top. 1.83 times 0.2 times 1 divided by 1, and then divided by 3.513, and that is equal to 0.102 cubic centimeters. Okay, so I'll post these notes. Actually, it's already posted in the lecture 5 notes. That's there. What else? Oh, it's just showing the conversions there. So let's jump back to OWL. All right. So I can't type that number in here because this has a certain, this is a different amount of carats. 14 carat diamond? I wonder if it's here. Probably does. Now what do we got going here? We've got metal slug giving us the mass. I'm going to jump ahead. Density. Okay, so we're doing density as mass over volume. You guys getting the hang of this? It's tough here though. A metal slug weighing 25.17 grams is added to a flask with an existing volume of 59.7 milliliters. It is found that 45.1 grams of methanol must be added to the metal to fill the flask. What is the density of the metal? It's interesting. Okay. Wow, this sounds hard. What's going on here? Well, what's going on here is you got some kind of flask and they set a piece of metal in here. Well, we know what the metal weighs, 25.17 grams. And they said the entire volume of this thing is 59.7 milliliters. So this is the total volume of what? Well, it's going to be the volume of the methanol they pour in there, plus the volume of the metal. How did I know that? Just kind of reading the words. I've seen this experiment before, so that helps. But I'm just kind of trying to visualize what they're saying here. All right, so it's found that 45.1 grams of methanol. So they had to fill the rest of this in with methanol. I'm going to abbreviate it meth. No snickering out there. All right, now I got 45.1 grams of methanol, and I'm going to use the density as a conversion factor, and the grams got to go on the bottom so they cancel out with those grams. That's going to give me the volume of methanol. Goes up there. Now I can take that volume of methanol and subtract it from the total volume, 59.7. So the volume of the metal, this is like a fun displacement one. This is actually pretty similar to what we're going to do in lab. The volume of the metal is equal to the total, 59.7 milliliters, minus, we'll just call it the volume of methanol, okay, that we get from that calculation up there. Now, once we get the volume of the metal, that number can just go all the way up into here, and we can use that with the mass of the metal, 25.17 grams. Okay, so we're getting at the mass, we're getting at the volume with some different ways here. Oh, that's pretty fun. Let's keep going. Oh, decide which one's more dense here. Yeah, just give you a few pointers. I think you guys can figure this one out, but orange block, blue block, well, it's got a smaller volume and it's on a balance. So if it's heavier, then it would go down. So it's heavier and has a smaller volume. Okay. And if it's heavier, that means this number is bigger, smaller volume. Both of those are going to make the density bigger. So this thing's probably pretty dense. I'm going to go with, it says which one's more dense, the orange. Yeah. And then if things are the same volume by looking at it, but this one's heavier, then I bet the blue one is more dense. So you get to look through some of those pictures. And so I did a couple of those right. I got a couple wrong. So I got partial credit. Let's go on to the next one. Density of osmium. Ooh, what do we got here? All right, the density of osmium. Well, they already told us 22.57 grams for 1 cubic centimeter. Volume will be occupied by 3.09 kilograms of osmium. All right, so I'm just going to help you set this one up. So remember, don't start with the density, start with the kilograms. So 3.09 kilograms. Oops, that's not going to cancel out with grams, so I have to convert to grams. There is, in per kilogram, there's 1,000 grams. Now I can use the density, 22.57 grams is 1 cubic centimeter. File the numbers on top, 3.09 times 1,000, and then divide by 22.57. In that, let's see, kilograms cancel out, grams cancel out. Oh yeah, I'll have nothing but the cubic centimeters. A lot of problems are solved just by looking at the units. Okay. Next one, what do we got here? Ooh, this is the Raiders of the Lost Ark. I had a picture in my notes real quick because I knew this problem was in here. And Indiana Jones, he's trying to steal a gold idol and doesn't realize how heavy it is. And he tries to replace it with a bag of sand. And so, I don't know if I want to spoil this one for you guys. So I'm going to let you work through it. Okay. And you got to think about, it has the same volume of sand as the idol, the little gold idol. And he tries to replace that. And there's a mass trigger on there where if he doesn't do it right, he could trigger some dangerous traps. Spoiler alert, he does, because he gets the density wrong. All right, so we're going to move on to the density of the atom, of an atom. Ooh, I got this one too in PowerPoint, so we're gonna click over to that. Radius. Okay, we're going to find the volume of an atom. Now these are small. The radius of a helium atom is 32 picometers, and remember, pico stands for 10 to the minus 12. So you can think of this as 32 times 10 to the minus 12 meters, and that's its radius, okay? And its mass is 6.6 times 10 to the minus 24 grams. What's the density of the atom in grams per cubic centimeter? Ooh, okay, so how do I get grams and cubic centimeters? All right, so we got to do something here. We got grams, so we're good on the grams, right? So, but for density, we not only need the mass in grams, which we got right here, we need this volume in cubic centimeters. So that means we turn this, we got to turn the 32 picometers to meters, which I did, 32 times 10 minus 12, and then into centimeters. Okay, so I got this on the next slide here. All right, so in order to turn it to centimeters, I turn the picometers into meters, and then meters into centimeters. Because there's 100 centimeters, or 10 to the minus 2 meters in 1 centimeter, and this allowed me to get to centimeters. Now, when I stick that in the volume of a sphere calculation, 4/3 pi r radius cubed. When I do that, I'm not only cubing this number, I'm cubing the units. And so that will give me the volume in centimeters. We know what the mass is given in the problem. Then I just take the mass, divide it by the volume, and I get the density of the helium atom, just one single atom, 48.4 grams per cubic centimeter. That's way more dense than osmium at 25. This is talking about single elements, atom of helium, instead of having a whole group of them as a gas. So try not to get, don't read into this too much. This is not, doesn't mean helium is heavier. We know helium is very light, but the atom itself is quite dense. All right, back to OWL. We're almost done, you guys. We're almost done. We did this one in class, you guys. We did this one in class. You're given a mass of a sample, and you look at the volume displaced. So the volume of the metal is equal to the volume final minus volume initial. So you're just going to subtract those two volumes to figure out the volume there. Oh, go look at the notes there from class. All right. Lastly, what do we got here? At room temperature and pressure, classify each of the following macroscopic samples as a solid, liquid, or gas. Seems kind of strange, but okay. Steel is a solid, water is a liquid, helium is a gas. Interesting. In the following descriptions, the particles are atoms, molecules, or ions. The particles in contact, but move relative to one of each other. Highly compressible. I think gases are highly compressible. Particles in contact, but move relative to one another. That sounds like a liquid. I think they're trying to ask like particles in the distance between here, which has to do with density. So I can see why this is related. And it's just a little bit of thinking through on some of those properties. Hey, I'm going to cut it short here. Go practice it. Remember, OWL gives you some explanations. Don't forget to hover your mouse over some of the problems if you get them wrong. Okay, we can go back here and please try again. So yeah, it can often give you some help. And you guys can do this. This density thing you guys can figure out. All right, that is it for me. And we're going to call that one good for now. And we'll see you guys in the next video.